Happy New Year! Hey, my name's Rich and this is the First Layer. We're here to talk about printers in all regards, A to Z. This is kind of a helpful little Saturday show that we're doing for everybody. We just wanted to kind of get stuff out there and whatnot. And it's a wonderful 2001 today, January 1st. So congratulations for making it. Yeah, that's about as far as I can take an April Fool's joke. But anyways, hey everybody, how we doing? I got a bunch of little stuff to talk about, but because our friend, the Poor Boy channel, was in here way early, complaining about a problem he has, which looks like it has to do with his ex, I'm going to start you on a path on how to resolve that issue right now, so as this stream progresses, you can let us know how it's going. Does that work for you, Poor Boy? Come on, you can type. I've had 2 energy drinks today, so this could be a little wild. Oh, hey, we got Woody. Poor Boy, sweet, awesome. All right, so Poor Boy channel, what you have is an issue with your stepper driver in some way, shape, or form. The first thing I want you to do is take that stepper driver that's on your X, turn off your printer. First thing first, turn off the printer completely, unplug the power. Remove the stepper driver off of your X driver, or your X pins that you have for your X motor. I want you to make sure that your jumper is in the right location. It should be in the UART location. It might be in STI mode. It might be, you might have not removed the jumper at all. You might have removed all the jumpers. Make sure your jumper's in the right location. If it is indeed in the right location, what I want you to do is basically take your Y stepper driver, put it where your X is. Take the X one you removed previously, put it where your Y is. Restart your printer, see if you get the same error. If you get the X error, let me know. If you get the Y error, let me know. We're all gonna be waiting for you. All right, so let me look in the chat and let me get the chat up on the screen here too. Let's see, main with chat, there we go. There we go. So along with all that, friends of the channel, the First Layer, DeWitt 3D, Golden, Jaguar, all those people, hello. Patrons, SK3D, Mark Davis, who else am I missing here? Mark Davis, SK, oh, Brad. Thank you still, and I really do appreciate it. It does help out. Allows me to do some cool stuff. I do have a throwback today. We're actually going to be playing a little bit with an Ender printer, and I got some strong opinions about that. And it's going to be your choice to figure out if I'm completely BSing you on some of the things I say, or if I'm actually telling the truth on how I feel about things. And it's more or less feeling stuff. So I'll be looking at the chat, see who picks up on what, and we'll have fun with it. This is going to be a fun stream. It's April 1st, 2023, not to be confused with January 1st, 2021. But nonetheless, let's see. Let's see, Poor Boy channel. Oh, now that's cool. Okay, that was back. Please do not adjust your screen. Hi, Poor Boy channel. Do you have to config for sense resistance in the TM? Yep. Let's work with the hardware before we work on software. My suggestion. Just do what you want, but that's a suggestion. Sweet. Woody. Yes. Hello. There we go. 10-4. Cool. Got a little scratch in my throat. So I've caught up on all the chat, so we're good there. And what I want to talk about right now is a little bit about this printer right here. Let's see, what's the best camera? This one probably. This one right here. This is my Ender 5. And I gotta admit, I really like my Ender 5, even though I haven't given it much love lately. You can tell by the half-inch of dust that's on it. It gets dusty down here in the basement when something sits still too long. And this thing has been sitting still way too long. So I really like Enders in general. I do think, however, Creality kind of ruined the hobby by releasing such cheap printers. You know, some of them work really well, some don't work so well. They do require a fair amount of maintenance. Some require upgrades just to make them work halfway decently. But it is what it is. Oh, see, my Ender 5 has been great too. Mark, awesome. So all that being said, a little bit about my Ender 5 in specific. This on top of this is a Micro Swiss direct drive hot end, or not hot end, drive extruder section up here. Runs with the same motor that came with it originally, only it's moved from the side where the Bowden tube extruder normally is. There's too many E's. And placed up here. This is a pretty nice setup. It's pretty simple. I mean, it's actually extremely simple. It's a dual gear driven unit. I don't know if my other camera will see that or not. Let me try real quick. Let's try that one. Yeah, not really, but basically it's a dual gear driven unit right here with mounting here for the original factory hot end or the micro Swiss hot end that you can put on here. Dry throat. Have a little drink here real quick. I don't think I've looked at the model of a printer detail before. The belt's running and the channel along the extrusions is interesting. Oh, right here? Yeah. I'll go back to the other one real quick. Yeah, they don't really run in the channels per se, except for on the ends. It's part of the, we'll say, cheapness of the printer is the fact that they utilize, this is one of those things where somebody designed it obviously in an Asian country and got the most out of what they could get out of for the least amount of cost to build something that works. Jeez. Sometimes that works awesomely, other times that works horribly. In this particular case, it works pretty awesome. And honestly, I was going to completely complain about Creality and printers that they manufacture today, but I really don't have the heart to do it. My actual thought process is if Creality didn't come out with the Under 3 and the Under 5 series printers and the CR10 and a lot of those printers they came out with were, you know, nearing the $100, $150, $200 price mark, depending on when you bought them and to what equipment you bought them, there would probably be half the amount of people in this hobby now, because this is kind of the gateway printer that people get into in order to start printing, and they print awesome things. I mean, this printer right here can print just as well as any other printer can, if it's properly tuned, maintained, and working properly. So let's see here. All right, yeah. So, anyways, getting back on that, this is my printer. It's printed everything from PLA to ABS to polycarbonate. And I want to pause on that polycarbonate thing right there because a lot of people think I'm half joking when I say that, but this right here, if you don't recognize it, is the air duct for the part cooling fan for the afterburner. It is not a perfect print, but it's pretty darn nice of a print. And the only way I can really kind of prove that it's polycarbonate, if you don't believe me for whatever reason, is by hitting it. It sounds almost metallic. And that metallicness is because of the stiffness of that polycarbonate. This was printed on this Ender 5. The only thing I had to do for cleaning it up was I sanded the back here a little bit because it was slightly warped, but not enough where I couldn't use this part. And polycarbonate is extremely hard to print. It's right up there with nylon. Probably the only real printing differences between nylon and polycarbonate is a couple degrees, and obviously nylon is very, very, very hygroscopic. So polycarbonate doesn't have that. So not to get too far down this path, but if you do have an Ender printer, or you don't have a printer and you're just into printers and you're watching this, one of the first things I would ever suggest anybody gets is a glass bed. If you look for something cheap, something that you can do nearly anything on. The good thing about these is you can put, you know, surface preparations on this, like hairspray or glue stick or, what's this called? Magic Goo, something like that. And these are easy to clean off. You take them up to the kitchen sink, you put a little Dawn detergent on them, or Ivory, or whatever type of detergent you have, and give it a good scrub, and you're ready to go anew. This is 3 years old, and it looks like new still. Back to the polycarbonate thing, and the question as to how in the world do you print polycarbonate on an Ender printer. If you've ever tried printing polycarbonate, you'll know what I'm talking about. And this is my Magic Bullet. And I do have a video about it, but it's probably a little old and probably not that great. Still learning how to do my videos, but this guy right here, this is a polycarbonate sheet. I believe it's 3/8 inch. I did stick a magnet on it And what I did is I took this, I roughed it up with 180 grit sandpaper. I put this on the bed, and that allowed me to print my polycarbonate on my Ender 5. So we haven't heard back from Poor Boy, so either he zapped himself, or he's on to something good, or he's on to something bad. So Poor Boy, where you at, man? Looking out here. All right. You guys get all quiet when I start talking. Everybody should be talking and chatting and having fun. This is a fun stream. Look, I'm drinking energy drinks and I'm really hyped up. There he goes. Didn't work. What'd you get for an error? What did you find? Did you find you had the right jumpers in the right location? And did you get an error still on your X, or did you now get an error on your Y? We'll just wait. It's kind of hard because chat's over there and you're right there. All right, I'll come back to that. All right, so one of the reasons why I dug this out is I got contacted by a company called Per Gear, and I don't normally take things for free. Oh, there he goes. Same thing, check jumpers, they're correct, same error. All right, so you got an error on the X, but did you move the driver to Y, move Y to the X? That's a clincher to make sure that that stepper module is good. But anyways, yeah, Per Gear wanted to send me a hot end for this particular printer, or actually any Creality printer. So it's a Creality Spider hot end, and I figured I'd talk about it a little bit. I have it right here, and I'm going to throw it on the printer right now. It's going to be replacing the micro switch, which I've already taken off, and just go over a couple of things. I looked at it briefly, but I didn't want to talk about it because a lot of people still have these printers, and if you do, you can get good use out of it, to the point where if you upgrade it enough and you do want to build a Voron, you haven't built a Voron, or you need additional parts and you use to print it forward, there's no reason why, with the right tuning in the right environment, with some modifications, you can't print your parts with an Ender printer. So let me get back to, I think, this camera? No, I want the other camera. Yep, same thing, check jumpers. Yep, so you switch over. So you're still getting the error on the X. And if that's the case, then you might be looking at software. Who was it who was talking about software? Whoever was talking about software earlier, what was it, on the sense resistance? Are you running this sensorless, Poor Boy? Let us know. So here is the Spider hot end for the Creality Ender series of printers, and also the CR10. And this isn't kind of like a promotional thing or anything like that. It's just something I wanted to do since I have it. There you go. Thank you, Nick, for putting that up. Oh, by the way, Nick, Rich wanted me to let you know that he now is a moderator here, so you better behave. And if not, then he's going to put you in timeout. So FYI, you've been warned. So just a quick comparison between the Spider and the original, and also the Micro Swiss. They all look similar. Obviously they're hot ends, so they're going to look similar. But the Micro Swiss and the original Ender hot end, everybody's seen one of these, has had an Ender printer, are very similar. There's not a lot of differences between these two. They use the same heater core, they use the same thermistor. The Micro Swiss is a little bit chunkier in terms of the cooling fins on here. Probably manufactured a little bit better. Overall, it does have a slightly larger chunk of metal down there at the bottom. So overall, it's kind of pretty much the same though. So let's compare the Micro Swiss to the Spider. Spider is the same height and length, so it's a direct replacement, drop-in replacement, if you will. It has a very small sock on it because it's kind of following suit with the Revo and the oh gee whiz, the Fadus. What is it I'm putting on my printer? I forget. Anyways, the hot end, the heater core is actually a 360 degree heater ceramic heater that's around the bottom section of this. They've also improved the cooling on this by making these fins a little bit smaller and having more of them, so it allows for more air to dissipate around the unit as it heats up. The only modification that I had to make on my printer to install this, and it would have been even if I didn't have this micro Swiss end on it, because again, they do have the same mounting points and they are the same size, was I had to put connectors on here, which I didn't have to do. You could easily cut them and solder them. Matter of fact, on this one right here, I didn't have the proper connector. In the packaging for the Spider, it came with some connectors. I could have reran the whole thing, but I wasn't really interested in doing that. So I went ahead and soldered them in line. They're nice and sealed, and heat shrunk around them, so they're nice. And those aren't going to move much, so they should be good. I did, however, have a connector for the actual hot end, so I did replace that, put a new connector on that, which is going to mate up with this new hot end. So changing the hot end on a Ender style printer is pretty darn easy. I'm going to take this retainer out real quick. I'm going to slide this right up. It's awful dry. And I'm just going to use the 2 screws that they provided, which are a little bit longer. And we're going to tighten those up a little bit. And kind of giving some love to this printer because I haven't seen it in a while. And I went ahead and I adjusted the tension on the wheels so this was a lot stiffer. It actually over time had loosened up, and I never really gave it much love. Sense resistor 0.00. Okay, you guys are working that through. Looks good to me. You guys are in the software. Software is always more difficult to troubleshoot than hardware, in my opinion, because you're dealing with variables, and everybody's printer is going to be slightly different, even if you follow the same instructions. So I'm gonna tighten that up right like that. Put that on. And then I'm gonna just wire this up real quick. So like that, and like this. And this end is running clipper already. Get rid of those. Pop up this retainer. Put that on. Looks good. Let's see, poor boy. Status indicator on the board is red. Red can be good or bad. I'm only half listening to what you guys are over there doing. That's what we're all about, helping each other out, so that's good, right? And what I don't recall is exactly how this wiring was. Obviously don't want it around that. I want to keep everything away from that hot end as much as possible. So we're going to keep this up like so. And that puts us right about where we want to be. And then I simply got 2 screws to put in for this. One of which is for this shroud here, this fan shroud. This is probably the most difficult part, where you could use 3 hands to do it. Come on. Yeah, we'll just get that screwed in. I'm not gonna tighten it up because we also got to put our touch probe in. Just wanted to hold that real quick while I do that. And I forgot it actually goes on both screws, so good thing I stopped. And what I'm going to do is the BL touch on this actually goes on first, because you want that to be held as tightly up against the rest of the printer as possible. It's the more precision part versus the shroud, if you will. Let's get that started. Get the second one in there. So when I originally got this printer, it did not have a BL touch or any touch. And what was that screw? There it is. So that was an addition for me. This was a very base core printer when I bought it originally. But modifications wise, I think having a touch probe of some sort is very smart, unless you like adjusting your printer more than the average bear. Getting clipper onto the printer, however you do that, is good. You may have to upgrade the controller board. I did on this one because, again, this was a very base model and it was relatively old. But the newer ones you shouldn't have to do that with. And outside of that, an all metal hot end is a necessity if you do want to print with the hotter plastics. Pretty much anything. You probably get away with PETG, but that would be the limit, I would say. And some people probably would tell you that you can't print PETG with a non all metal hot end. I think that's arguable. So that should be good like that. Just gonna check my path. I thought I had a piece of filament someplace over here. What are people saying? Sense resistor, see? It seems that is right value. Not sure. Sense resistor, not sense resistor with a space. Oh, good point. I want to make sure you have everything written in the right way. Let's see here. Let's make sure our path is good. Yep, path is good. Awesome. For some reason it thinks my hot end is negative 41 degrees though, but I have a feeling I know why. That's because I had my thermistor disconnected. So let's take a look at that for a second. And to do that, let me bring this guy over to here. Oh, nope, that's the wrong printer. So used to using that printer. Where's my other printer? Well, let's just make this that printer. Here's the Cave Ender 5. And let's see here, screen now. Cave Ender 5. So this is my oldest version of Clipper and my oldest printer running Clipper. So it's been a long while since I've done anything with this, so I'm not going to be surprised if we don't have a few little issues here. Yep. So there's some depreciations here, whatever. None of these are going to stop me from printing. But what I want to do now is I just want to heat up my hot end, make sure that it actually goes up and the thermistor sees it. So we're going to heat it up to 100. And it's giving it power, which is good. And it shows it going up. All right, I'm going to heat up to 220. Let it go all the way up. And that is heating up actually really quickly. That's kind of, it's actually kind of impressive. It's drawing down them electrons. And where is my live stream window? And chat. Sense resistor. Make sure not sense resistor or space. Nick, that sounds right. No expert Clipper configs. I'll get into my Clipper config on this printer in a second. So we're talking about the, why are we talking about resistor with the X driver? Just out of, not to question too much because I'm not able to follow as good as you guys when you guys are reading a screen and not doing things with your hands at the same time. But I thought he was having an issue with his X driver stepper. I'm just wondering why we're looking at resistor. Maybe I missed something. Who knows? All right, we're at 221 and then it's gonna go back. I have not done a PID tune, which is something you should definitely do if you change your hot end. But I just want to basically see if I can run some filament through this real quick. So I'm gonna grab this and at the same time kind of give a view of this little setup here. So what I'm going to do is, now that I have that, it's up to temperature. I don't need anything on my bed. I'm just going to come down here and do a quick extrusion. I'm going to home the whole printer, which it should do just fine because basically the hot end I put on there is the same height. So the PL Touch should work just fine. I guess I can show that so you guys will see it, right? So it's homing the Z right now. I am going to hover on the emergency stop because I'm told it's the same, but yep, it's good. click. Yep. All right, we'll home that. All right, and I'm gonna actually extend my Z. I'll go back to this. Actually, no, I'm gonna leave it here. I'm going to give myself some space here. And a little bit more. And I'm just going to basically run that filament through and make sure that everything is working properly real quick. And we'll extrude 50 millimeters. And it seems to be working just fine. Yep, that seems to be good. Awesome, that was very, very easy. I'm gonna cool that down real quick. So let's go ahead and bring this down to about 160-ish. And I believe that was, yeah, that was ABS Plus. We put through this. So it was kind of cold for ABS Plus. This is very cold for ABS. So when we get down around 180, 160, I'm gonna warm pull this real quick. And I'm gonna talk a little bit about cleaning filament since this printer needs a good cleaning. So I'm gonna cold, warm pull this, whatever you wanna call it, like that. And I'm actually going to show on camera here. Let me get my this one right here. Yep. See if I can show you that real quick. I don't know if it's going to come up very well at all because that's really close, but that was kind of a cold pull on that. And see how there's a little bit of greasy, dirty, grimy stuff on that? That's going to happen with any new hot end, and that could frustrate you to God's green earth end if you have any machining, lubrication, or metal filings or anything in there during the manufacturing process of a hot end when you first put together a printer, you first build a printer. So I was actually talking to Rich a little bit earlier about this. Where's Rich? Check this out. Okay, let me read this real quick. Sound right, no extra clipper C, clipper that's right. Clipper errors, parse errors, sense resistor, in section, TMC. Yeah, I want to know why the resistor part is talking about stepper X. Rich, it looks like you got a video there. If you could throw something up and let me know what's going on there. We're talking about resistance of, if he's running it in sensorless homing mode, maybe that makes sense. But other than that, I don't know. That's usually a current thing, not a resistance thing. When the stepper takes too much current, it basically makes it know that it's hit the end stop. Yeah, anyways. So cleaning filament. So yeah, so if you guys don't know, Rich from the First Layer also does a side hustle for filaments.ca since he's in Canada, and we don't hold that against him at all. Or the other half of the people that are on the stream, they're also in Canada. But I was asking about, I've never used cleaning filament. I honestly haven't. So I was asking him about it a little bit, and you don't see much about cleaning filament. And I said, is there anything special about cleaning filament? Like, what's the deal with it? And what I noticed is that first on the package, it wants me to run this at about 300 degrees. And secondly, it's almost as flexible as a flexible filament, but not quite, which is also interesting. So I'm gonna cut myself off a piece of this, about 2 feet long, or what would that be? Oh, I don't know. Where's my converger? My ruler. 2 feet long would be, oh, probably around 800 millimeters, 80 centimeters or so. And let's see. Message retracted, no weird formatting things. Thanks for, I'll be right back. All right, Poor Boy's gonna go watch that video real quick. Usually, here's what I'll say. I don't know if Poor Boy, you can still hear me or not. You're probably looking at the other video. But when he comes back, if you still have an issue or whatever, is usually when you have an error with your clipper config, your printer.config file, is it usually will tell you kind of where that error is. So I'm kind of questioning that he has a configuration error. He might still have a hardware error of some sort. And usually a sense resistor. Can anybody explain to me why we're talking about a resistor with his driver. Sense resistor and section TMC stepper X. I'm not familiar with that. I'll have to go look in my config. Back to this, and back to this cleaning filament. So I got myself my 2 feet cleaning filament, and I'm going to actually ramp up my temperature on my printer as soon as I get this loaded. As soon as I get this loaded, put a little chamfer on that, little notch. It's a small coil and it's fighting me a little bit. There we go. Okay, got that in. And I'm actually going to heat this up to, I don't remember what my max is on this. So let's go up to 280. Max is 265. All right, 265 it is. We'll heat up to the 265 max, and it will probably error out on us when it gets to 266 because we haven't done a PID tune and it's going to overshoot it completely. But that's part of the fun, right? You could have the X set to TMC 2208 instead of a TMC 2209. That would throw the error. Okay, good. Hopefully he comes back and he reads all these messages. Woody, did you fall asleep, buddy? I don't see you talking at all. I know you don't have much about that conversation, but I like to talk to you guys too. You guys like talking to other people, not me. It makes me feel bad. All right, we're at 259. Let me show the screen off a little bit here. Where's my screen? There it is. This hot end is heating up extremely fast. Really nice. I'll see if it overshoots. Oh, look at that. I knew that was going to happen. I told you that was going to happen. So I hit my max temperature, and this is actually a good thing. And for Woody and the folks out there that have not done a lot of printing, this is a completely normal error. And I kind of am happy that I hit this, because basically this is the printer telling you that it's out of whack. This is too hot. I don't like it. I'm shutting down. Power's getting dropped on everything before I burn something or break something or something melts. So that's a good error to have. I'm gonna have to restart the firmware though. Basically need some intervention. And we'll get our thermals back up, or I drop down. So we'll go to 260 because that should be safe. It won't overshoot that. If you go to really maximum, you probably should never go within 3 degrees of your maximum because you're gonna overshoot it. Practicing Fusion 360 on the CNC tap. So practicing Fusion is more important than watching my video. Understood. I get it. It's okay. Not hurt my feelings at all. It's okay. I know you're doing both. All right, let's see here. Where are we at? We're at 261.5, so it overshot it by 1.5 degrees. And now it's reducing. It's basically finding its middle road. We'll wait for it to even out a little bit. Split screen. Split screen with Fusion does not sound like fun. But then again, Fusion for me is not fun yet either. Just nylon. You know, it kind of has the similar. It could be. Actually, Rich, do you know? Is it just nylon? I don't think it's just nylon. It doesn't seem to be just nylon. It seems to be melting at a little bit lesser temperature than nylon because it's already starting to ooze a little bit. But nonetheless, all right, so we got this in here. It's loaded. We're up to 260 degrees, which is pretty warm. I'm going to run through about 100 millimeters of filament. Or I'm going to attempt to. I have to home first. Oh no, it's going. Actually, let's go to that. There we go. She's coming out. We're going from white filament to clear filament. It's kind of magical. I'm probably gonna have to do this another time. We're gonna do a total of 200 millimeters of filament. There's the first 100, and let's extrude another. It's coming out nicely. If I was smart, I would have ran a brighter or a darker color before this, but white's just what I seem to have had on hand. Yeah, so, all right, so we got that right there. That's our 200 millimeters of our cleaner to clean that out. And now I'm gonna drop this down 5 degrees, which I probably don't because I'm only at 260, but we're gonna go to like 255. So just gonna drop it a little bit. And we're just gonna get time to kind of solidify just the meaningful amount. And now we're at 205 or 255. I'm gonna actually do like a hot/warm pull on this. And see what I got. And I don't have a lot, but I didn't expect a lot from this. So at this point, I would consider this printer with this new hot end ready to print with. That's that. So we put new hot end on this, which is something I want to get done. I got it done during a live stream. People got to watch it and see it and be happy. And maybe Creality is happy that I showed off their new hot end that they sent me. I will have a video, an unboxing of that too. So you should see that at some point. So let's see, first layer by default, blah, blah, blah. It has a nylon base, but there's a cleaning agent to attract junk to lube the nozzle. All right, so does that mean, Rich, the first layer, that I should store this in my dry box? Let me know. It's kind of dry right now, but it won't be come next month. Okay, so I'm gonna put these nozzles away, and I'm gonna get some printing done with this ender, but not today, because I don't want to do printing with this today. I want to talk to you guys. So this is my janky, by the way, my janky setup for my ender with my clipper. This is my Raspberry Pi right here, plugged in via USB on the front of it. It gets the job done. That's pretty much what it comes down to. I'm gonna go ahead and throw Old Faithful back on here. Actually, before I do that, let's turn these stepper motors off. Steppers off. I said steppers off. There we go. I'm gonna clean that up real quick before I put it away. My favorite cleaner down here in the basement is my ISO spray. So I had a really good question that I haven't seen anybody ask before, and I had to look it up a little bit. But in the end, it kind of was what I thought it was going to be. But somebody asked me on the titanium backers for printers. Since you have two dissimilar metals, they didn't word it like this, but I'm going to word it like this. Two dissimilar metals on your printer with the aluminum and the titanium. Is there any galvanic rusting or oxidation that's going to happen? And I did a little research, and I answered the question of the person on the comment section of my YouTube channel, which most of you probably have been to, but obviously don't hang out there all the time. And I'm gonna go off camera here for a second because I'm gonna go get rid of this. But anyways, they asked about the galvanic reaction between the aluminum and the titanium. And my first thought was titanium probably is not very reactive, which is part of the reason why it's used, you know, for fake or for repair in the human body. Titanium hip, titanium this, titanium that, titanium screws holding it all together. And that is true. However, it turns out that titanium, when in contact with aluminum, actually does cause the aluminum to oxidize quicker. So I was thinking to myself, why would they do this? This was starting to worry me. And when I start to worry, I start to read more. Let's see here. Firstly, yes, I should put it in my dry box. Cool. Justin Simons is back. All right, cool. Yes, sir. Let's see here. All right, followed the link set up for TMC 2209 as shown. Now there is changed, unable to parse run current in section. Okay, so I would say there's the syntax of your run current is probably got an issue with it. You should have a run current and a hold current, and I think there might be another one in there too. If you'd like, I could bring up my printer config on, well, if I brought up this one, you guys would be like, that ain't gonna be very helpful. It's because we disconnected that one, but I can bring up the printer config on my other printer if we want to do that. You let me know, poor boy, I'm more than happy to do that. So I'm gonna clean up a little bit. So back to that galvanic response between the titanium and aluminum, it was kind of worrying me a little bit. So I start reading because I'm worried, and here's the deal. Yes, it will cause oxidation, but not only are my titanium backers coated, but obviously the aluminum on your printer, on your extrusions, are also coated. So the chances of that happening are slim to none, especially for the allotted amount of time that you're probably going to have your printer. And then you couple that with the fact that if you're printing, you're probably not doing it in a hugely moist environment that's going to exacerbate that. So I don't think it's a big issue. If it's run through your mind at all, I would get it out of your mind. It's not a big deal. Don't worry about oxidation between your titanium backers and your aluminum extruders any more than you would worry about your aluminum extrusions and your steel linear rails, is how that comes back. So let's see, we're gonna have to put our cleaner filament in our dry box at some point because Rich says so, which is cool. All right, so, oh, let's see, Chuck, hey, how are we doing? I didn't know you were here, Chuck. Is there some way to have the controller fan turn on when the printer is powered on or reset other than plugging them in to an always on port? Which particular fans are we talking about? You're talking about, keep the pie cool. So you're talking about the fans on the bottom in the compartment bay, I assume? I don't know if you can have them on all the time, but you could definitely run a macro. And I'm down here now, I need to adjust this camera. You can definitely run a macro that's going to keep those fans on for much longer than they'd be on if you didn't have a macro going or something. You could put them on an always on port. Is there a reason why you wouldn't want to do that if you want them on all the time? Just kind of the simple, easy question. Sometimes the simple way is the easy way and the best way. We're all fiddlers around here, so we like to make things complicated. Sometimes forget that the easy path might be the best path. Could be plugged in always on port. Yep, that's what he mentioned. I don't want them running 100. Oh, so you don't want them running on 100%. Okay. So the mechanically inclined side of me says if you don't want your fans to run at 100%, but you do want them on all the time, a small resistor in line would probably be the easiest way to accomplish that. Other than that, you're gonna have to deal with macros. And those macros are going to pretty much be running at different times, but they're all going to stop at some point because eventually your printer is going to go to idle. And when your printer goes to idle, it's going to stop doing any of that stuff. So I'd say the only way to 100% have those fans on, if the printer is on, is to hook those fans up to a port. And somebody correct me if I'm wrong though. Hook those hook those fans up to a port that's always on. And if you want to reduce the speed on those, I think Chuck wants to be able to throttle them. Well, you can put a potentiometer on them. I mean, he's got that going. But the thing is, he wants it not controlled through the printer. He wants it basically to be dumb and running all the time. Dumb meaning not logically controlled. And if he wants to be able to throttle them, adjust the speed on them, then he could do it either through, you know, a switch with ABC or something. Multiple resistances, or even a potentiometer. Those are both possibilities. If you just want them on all the time at say 75 or 80%, you could do resistors. Resistors, you probably have to play around a little bit. It'd be pretty easy to figure out what you want for speed on those, but that would be relatively easy to do with a couple of resistors or so. Just put those fans together into that. I haven't seen the poor boy. Starts to make me worry. How about connecting the two fans in series? If you connect them in series, I mean, you might be cutting your voltage in half, which would, you know, probably get you around 50 or 60% of the speed on them. but I don't, it depends on how they draw and how they're working. That could be a solution if you wanted to, if you want to run them, say, around half speed. So that's definitely something you could try. Let's see here. Let me bring up this, and let's go into my very simple printer config. And we were talking about, what were we talking about? We were talking about our run current and our hold currents and our sense resistor. I'm still here just reading and searching. Okay. Poor boy, if you want to look right now on my screen, I know you can hear me, but if you can see me, I've brought up my printer config, and what I'd like you to do, and yours probably isn't exactly the same as this, but it should be pretty darn close. The biggest thing that probably isn't going to be the same is the UART pin. This is on my old, this is on a spider board, so this is probably going to be different for you. But your run current should be formatted like this, your hold current should be formatted like this, and your sense resistor should be formatted like so. There's no hold current. Okay. Well, I can tell you probably should have a hold current. Just to elaborate on that a little bit, your hold current is the current that the printer puts out to that stepper motor to hold its position. If you don't have a hold current on a stepper, then basically it's freely movable if there's nothing running in that stepper motor. So it's kind of like a parking brake, if you will, for a stepper motor. Maybe the fact that you don't have a hold current in there could be messing with you. I'm not 100% on that, but maybe somebody else knows. I don't think I've ever had a stepper without a hold current. I usually always have a hold current on all my steppers, including my extruder, I believe. Let me look here real quick. ZZZZ extruder. My currents. Yeah, I even got a hold current on my extruder. It's much lower, but it has one there too. Where did you get your config? Just wondering. Not saying it's wrong or anything like that. Just wondering where you got your config. I mean, that's part of the problem with all of this in my mind is there are so many places to get information, and it's not really brought together. And it's part of the part of the greatness of having an open source system is the fact that everybody can put in their own little thing. But in the end of the day, some of it's garbage and some of it isn't, and some of it's right down the middle. And sorting it out can be a little bit difficult for somebody that's doing stuff for the first time. I think it's kind of one of those barriers to entry type of things. So, yeah. The Voron GitHub base config. Okay. That should be a good base config. But again, often there are issues even on a base config or anything like that. And do note that it is a base config. It's to work off of. So, does anybody out there know if you actually can have a no hold current on a stepper? I wasn't aware that you could. I thought it was kind of a requirement in Clipper. So that's a good conversation point. All right, well, we talked about the Ender 5. We talked about polycarbonate. We talked about cleaning stuff up. And I guess we'll talk a little bit about my current printer build and where we're at right now. This guy right here, the Voron 2.4 R2 Ultimate build. And I'm pretty happy with the way it's going together right now. I've run into a couple snafus. One of the biggest ones I'm dealing with right now, and I don't know if anybody else has ever used the WaveShare 5.5-inch screen at all, but I will show you guys kind of what I'm fighting with here, if I can find the right camera. So the WaveShare screen that I got, that I'm going to put in the front of this printer, has its ports on the back side, which is good because you need them. And this is a 5.5-inch touch screen. It's going to run Clipper screen for me. And let me zoom in a little bit. And so the biggest problem is that by the time you hook up a USB cable, or an HDMI cable here, it's sticking out beyond the screen, which is no good. But it came with this. I've resolved some of this, I think, which allows you to basically hook up to a Raspberry Pi, or at least get that back up. And then I picked up at Walmart a basically an HDMI to an HDMI, so I can hook up my HDMI cable out of that. But then I also have two ports here, and this is kind of my question, is this port says touch and this port says power. And they're both micro USB ports, and what I'm wondering, if anybody knows out there, is do I have to run both power and touch, or can I just run the USB from my Raspberry Pi to the touch section and have that power the screen? Or do I need to do that and then also provide power to this from my 5-volt power supply that's already in the printer? It's not really a big deal either way, but it's just a whole nother wiring. I have to go to this one screen. It kind of takes the fun out of adding a 5.5-inch screen if I got to run 3 different cables to it. Not hugely excited about that, but if anybody knows that would be cool if you could throw it out. All right, so we'll throw that back in there. Some percentage run, it is some percentage run, so quick current. So now default, let's see, there is now a default, so it doesn't need to be separately defined. Okay. On topic of fans, Discord group, okay. It is some percentage of the run current. So it already runs a default, and nice haircut, thank you. Trident stepper settings with Warren, Octopus, and doesn't show hold back current. Okay, I've always had a hold current on mine, but like I said, this is actually running not an extremely old version of Clipper, but configs change over time, so why not? Yeah, so put that aside. So what is everybody else up to? Kind of got a chat going here. I don't really want to end this thing until we figure out what poor boy's problem is, but I honestly didn't have a ton to talk about. I do have a modification I'm going to be making to this camera, so I might as well start doing that. Hopefully nobody finds it overly boring. But this is the C920 camera. It's going to be going inside the Voron printer. And I need to modify it to add a little bracket I just printed right here, which means I have to pull the base of it off. Try might not need due to using screws in the Z-axis. So even lead screws sometimes have a standing or a hold current as well, because they will spin. They'll do around the under 5. That thing will come right down if you don't have hold current on it. So I will keep an eye on the chat while I go through this. I pretty much got to disassemble the bottom of this to get it going. You guys work on poor boy's problem, and I'm going to see if I get my stuff done. Waiting on tap parts and new rail for my 2.4. That's what Mark is up to. Mark, where'd you get your tap parts from? I assume you're going to get the new version of tap for the 24 volt, hopefully. And that does remind me of something I did want to bring up. Because I know possibly to a fault, sometimes I mention KB3D a little bit much here on the channel. But what's going on here? Where are my screw holes? Are they only on one side? KB3D is actually kind of going out there again and going the extra mile, and is providing all the folks that bought the original tap through his web store with replacement taps at no charge to the customer. So basically, if you bought a tap, and I'm letting people know that are here, you probably should have gotten an email, but if you haven't, you can basically contact Chris over at KB3D, and he'll be happy to send you a replacement tap. I believe about in a week or two, maybe, as soon as he has them completely in stock and able to do so. But that's quite a bit going there. So my daughter is on the stream. Hi, Dad. I am Haley. Everybody say hello to Haley. Haley is my daughter. She's obviously snuck and stolen a phone and decided she wanted to join the screen today. So hopefully she's being nice. Yeah, it is great customer service. That's kind of why I wanted to mention it. I totally forgot about it until you mentioned that you were waiting for your tap parts. So I don't know where you bought them again, but if they were through Chris, that's the type of person you're working with. If they were through Chris, I don't have anything against anybody, but that's just, I don't know. I gotta speak highly about somebody that's willing to do that. I need a little tiny screwdriver, a little Phillips screwdriver. Where is my little Phillips screwdriver? Well, this figures. Where is it? That was loud. All right. There you go. A bunch of people saying hello, Haley. Let's see. Have any had anything about CNC tap parts? I have somebody that I talk to about those CNC tap parts. I have somebody I talk to quite frequently that has them on order. I don't know much about them in general. However, I do have a general question about them, and I haven't dug into it all, but the back panel of the tap is meant to break away from the rail if you crash the tap. On the CNC part, I don't see any way that that could happen. So I'm a little skeptical as to whether or not that'd be a good move or not to go with that CNC part. If anybody knows or has any idea what the solution to that is, either now or in a comment later, that would be awesome, because I'm all for the CNC parts. Makes things nice and easy and clean. But some parts in specific are meant to have some flex in them or have break points in them, and that is one of those parts that is supposed to be able to do those things. So let's see here. I will talk about something else that's kind of neat while we're on the subject of talking about some odd stuff that's happening right now. Thanks for the great video. The gantry de-racking allowed me to find out that I was doing wrong with my Voron 2.4 500 by 500. That is a huge build, incredible. That's pretty incredible. 500 by 500 is, that might be the biggest Voron printer I've heard of. I'm interested. Is that yeah, it's 2.4, 500 by 500. Obviously self-sourced. Obviously difficult to put together, and I imagine pretty difficult to de-rack. The one thing I didn't do in that de-racking video was explain that after you put your tool head on the printer, you're going to want to go through a similar process again, because your belts, your tensioning of your belts is going to cause things to move a little bit. So do keep that in mind. Eventually I'm going to figure out how to take this thing apart. But yeah, it's awesome. I appreciate that. Bye, Haley. Everybody say bye, Haley, now. Ricky Regan actually ordered from Fabrico. Yep. So Woody, you're buying that CNC part, huh? Again, I'm kind of worried that's not, there's some intent in that part as it's printed in ABS for a fail point, and when you go with it in a CNC, you're taking away that fail point, so that worries me. But all the best luck to the people who buy it. Worst case scenario is you cause larger damages to the printer, but nothing that's not fixable, so it's all repairable. So I might just be overly cautious about that, but that's just me. Anyways, yeah, so I was going to talk a little bit about the beacon probe. I think somebody asked me about it last stream I did, and I hadn't looked into it much, but I've actually looked at it a little bit now. And my first knee-jerk opinion of it, for anybody that's looking at it or seen it, and if you haven't seen it, there are some videos out there. There's not many, but there's a couple. Is way overkill. That's kind of the first knee-jerk opinion on that. So for those of you that don't know and haven't seen it, what it is it's kind of a flat plane probe that uses induction, not induction, what is it using? I forget what it uses exactly, but nonetheless, it basically can scan the surface of the bed, giving you, umpteen hundred test points from your bed for your probing. And that sounds really cool and all, but I was jokingly talking with Rich about it and how eventually we're going to have to run i7s on our printers just to be able to compute the data they're going to get off these types of probes. I don't know why you would need that specifically. I think it's cool. It's along the same lines as to me putting a 4K camera on my nozzle. I don't think I need a 4K camera on my nozzle, but I think it's cool. So if you're looking for something that's cool, then I think it's something good to try. But if you're doing it because you just can't get a good first layer, I don't know that it's the direction I would go into. So somebody asked me about that. That's my opinion. Now that I've seen it a little bit more, and I'm more than willing to read if anybody else has looked at it much. Let's see, gonna print a Mantis XO when I put a Rapido on it down the road. Oh, what did I miss? Sorry, bye Haley, bye guys, okay. But there's no breakaway in a standard tool head, so what's the diff? The difference is that normally on a standard tool head, you have a probe on it, whether it be an inductive probe or something like that. Yes, with the tap, you don't have that. But since the probing part of a tap probe is using the nozzle, that's your probe. I mean, the nozzle is your probe. So if you're probing and you crash with your probe, there we go, finally, you're done. It's all you got. Whereas with the tap, with the breakaway, I don't know what I'm supposed to do here. I'm gonna have to look at the Git to figure that one out. If you crash your probe, I need to look at the camera for a second. If you crash your probe, then basically that tap will break away. You won't damage possibly your hot end. You won't possibly damage your linear rail. You won't possibly damage your extrusion going across. All those things come into play. If you're using sensorless homing, that would work, but I haven't heard of anybody doing sensorless homing with a tap. It doesn't make any sense. There's no way to do that really. Yeah, I don't. You're using the nozzle as the probe, so there is a probe, and then on a normal printer you have a probe on the print head usually in the form of an inductive probe, at least in the normal Voron build. So. Yes, the breakaway in the regular tap is plastic designed to break. Yes, so the part that basically you have the 50 millimeter linear rail that's behind it. The part that attaches to that 50 millimeter linear rail with the 4 screws, it's made thin on purpose because, and if you watch the original launch video for the Voron tap, they mentioned specifically that that's meant to break off and fall forward if there's a crash in the printer. So you're basically throwing that design, that engineering away, and that's your choice. You can do that. I mean, it's your printer. You do what you want to do with it, but there is a purpose behind it. I can print a CNC tap in ABS. I can print a CNC tap in ABS or polycarbonate. I'm not sure what you're saying there, Woody. When they're talking about a CNC tap, they're talking about aluminum. There's a manufacturer out there that's actually manufacturing a CNC'd version of the tap out of aluminum. So they, yeah. I'm modeling it right now. Okay, cool. The design. All right, I guess if you're doing it for fun, yeah. So anyways, yeah, I don't know that I would buy an aluminum tap. That's on you. A lot of the parts on the Voron in general, supposedly, and I haven't run the gauntlet to figure out if it's true or not, but supposedly a lot of the parts on the Voron itself are manufactured or were designed purposely so they had some flex in them. And as soon as you start modifying that stuff, you know, it's one of those old things where either it bends or it breaks. And in some cases, things are going to start breaking before they bend because they're made out of aluminum, which isn't the original part. What would be awesome is either over time or out of somebody actually taking the time to specifically look at it, is looking at which parts could be CNC'd out of aluminum on a Voron printer, and then basically have a list, because I would be pretty much willing to guarantee that 80% of the parts probably could be CNC'd out of aluminum, with the remaining 20% of the parts needed there for that flex and that you know, that little bit of fluidness that you need to make everything work together without making anything bend or break. You can also look at getting some of that filament that has carbon fiber in it. Yeah. Yeah, we were talking about a little bit. I think Woody, you were already here. I don't know, Incredible DIY, if you were here already, but you hadn't chatted. But I was talking about earlier about this. This is actually polycarbonate. This was printed on Ender 5, and polycarbonate's an awesome plastic to print with. This right here was printed with polycarbonate simply because on my afterburner on my other printer, this is one of two, the other one's on the printer. This is a known area on the printer to get a little bit too hot. It doesn't want to focus. So I printed out polycarbonate for the extra heat resistance. But when I was doing that, I also played with polycarbonate and looked at the wear resistance and some other things on that. I could probably do a video at some point on polycarbonate and printing with it. It'd actually be kind of fun to do a video about polycarbonate, nylon, and mixes of those two and different things about them, because you could also, you know, there's some awesome stuff you can print with that stuff. Decide to. Think of catching a live show, and what do you know? Yeah, well, what do you know? Well, anyways, what I was saying is on my Ender 5, incredible. I was able to print polycarbonate, so I was basically going out there and telling people that if they want to try something, they should go ahead and try it. You know, you can definitely 100% print polycarbonate on a Voron printer. You could print polycarbonate nylon on other printers as well, including the Creality printers. However, you are going to have to modify some parts or buy one that has modified parts that allows you to print that. The parts that you'd want to modify, again, for those that weren't here, on a printer that you buy to print these, I don't know what you want to call them, these more advanced filaments, like polycarbonate, nylon, those types of things, and some of the carbon infused things. And let me talk about that in a second too, about carbon infused filaments. You'd want to have an all metal hot end if you don't have one, which is kind of pretty common now, but a couple of years ago, not so much. You want to have a bed that can get up to at least 85 to 90 degrees. You want to be able to contain your printer, preferably not in a cardboard box, but some people do that. I'm not saying you should ever put your printer in a cardboard box, because that does not sound like a great idea to me. Creality and a lot of manufacturers make a Mylar enclosure that's nylon on the outside with the reflective Mylar on the inside. Those are really good for retaining heat. That's what I used. But yeah, an all metal hot end that's capable of getting up to around, you know, 260 plus degrees Celsius. A bed that you can get up to around 80, 90 degrees Celsius. An enclosure so you can get rid of any breezes and kind of keep that heat in. But with those three things, you can print just about any type of plastic you want. It might not be perfect, but it's a solution. Let's see, I wasn't thinking about videos on different materials and printing them would be very helpful. Ditto, awesome, okay. Well, I will, Rich and I don't know if Rich is still here, but Rich, I, and DeWitt 3D have been, and Golden Jaguar 2, have been talking a lot about doing kind of a roundtable type build video, or not build video. Well, we talk about that too, but talking about doing a roundtable kind of discussion video, kind of a, you know, meeting of the people without minds. How about that? Because I don't want to say that we know everything. None of us are experts, but when you get four people together, you know, it's just kind of like saying that two eyes are better than one, or four eyes are better than two. Four minds is going to be better than one. You're going to get more opinion, and with that, you can kind of take out of it what you want. But that'd be a really good discussion to have about materials. I got my background in some of the materials I printed on that are exotic. Rich has his background with working with filaments.ca and knowing a lot about those filaments and a lot of the calls and emails he gets about those. DeWitt's done a lot of printing, and so has the Golden Jaguar. So maybe that's a video we could do as a group, or maybe that's something I'll put on my own if we don't do that soon enough. Let's see here. Rich is here. Good. Glad to see you still here, Rich. You haven't fallen asleep. What probe are you going to use on your new V2? If we're talking about the one behind me right here, this is going to have a tap probe on it. It's got the original tap OptiTap board on it that was meant for 24 volts, but was later found to not be so great for 24 volts. So there was a trace on the back of the board that was cut that brought 24 volts to, actually, the components were taken off the board. I flushed out the board. There's a video on it. And then basically a couple of resistors left on the board. I basically took all the 24 volt components off of the board. And then in my tool head, my PCB on the 2-part PCB that's inside the tool head, that was modified to run 24 volts to the pins that are, or the pin that is required on the tap, and then cut the trace for 5 volts on the back. There are multiple ways you can do that too. You can run 24 volts as opposed to the 5, but I was using the same 5 volts that I'm using for some of the other stuff that's on the head, so that's what I chose to do with it. So that's going to be a tap, and it's running the old OptiTap. I do have one coming from Chris that I'm going to use in the other printer when I do a remake of that, which is basically my other 2.4. That's going to be a video series where we're going to tear down. Actually, that's really exciting. So there's a few people here listening, so content to come, right? So one of the series I'm going to do relatively soon after we get done this thing is we're going to do a teardown completely of a Voron 2.4. Look at what's worn on the printer, look at what maintenance the printer needs to have done after about a year and a half of use and a couple thousand hours. We're going to do those maintenance things, do that you know, the lubrication, the things like that. We're going to look at what's worn, what should be replaced, even if it's not required for a R2 upgrade. We're going to do the R2 upgrade on it as well. We're going to put CAN on that printer. I'm not a huge CAN fan, but we're going to try it. We're probably going to do sensorless homing on that printer. We might try something like the beacon, something like that. So we're just going to throw a bunch of stuff on it that I didn't want to do with this because I'm not sold on it 100%. When we do the other one, that's going to be real fun. Yeah, working for a filament manufacturer does help. Octopus Pro can allow you to set up a jumper for 5 volt, 12, and 24. Yes, that is true. And then you can set it individually for each output. With the board I have, though, I believe there's a 5 and a 24 output. I didn't want to manipulate those. I just wanted to use what was already at the board without having to bring up additional wire. So that's part of the reason why I didn't want to do that. So I did want, you know, a few moments ago I was talking about filaments. And I wanted to talk about carbon infused filaments because I think that's a very confusing topic for some people. And carbon's kind of like one of those hot words, you know, just like graphene or carbon nanotubes and those types of things. So a couple things about carbon. One is cheap carbon. So cheap carbon in filament is carbon powder. And it doesn't do much more than color the filament. Carbon powder does not help with anything other than provide some dark graphite-y black to it. So when you're buying a filament that has carbon in it, you want to make sure it has carbon strands in it. It doesn't have carbon powder in it. Those strands are still very, very microscopically small, or else they're not going to make it through. But they'll do a lot more than that powder will. So be mindful of that when you're looking at descriptions. And if you don't see it in the description, ask the manufacturer before you spend a lot of money on a filament, because those carbon filaments tend to cost a decent amount of money. On top of that, the reason why you'd want to use carbon infused filament, there's 2 or 3 reasons I can come up with off the top of my head. One of the major ones is strength. A lot of people are using filaments with carbon in them for additional strength. I would possibly consider that with ABS or ASA. I don't think I would even look twice at PLA or PETG with carbon in it. It just doesn't seem to make sense to me. That's your strength part. The second part to that would be ease of use. So a lot of times when you add carbon to a filament, it does, and this is one part of ease of use, It allows the heat to travel through the filament a little bit easier, which means that you get more consistent melting because you basically have a metallic or a semi-metallic source inside of that filament rather than just a plastic. So basically it makes it a little bit easier to use in that sense. On top of that, because you have those carbon filament, those carbon hairs in there, again, they're microscopic. It helps with keeping your higher end and your harder to print plastics from warping as much. So that's really important if you're having trouble with ABS or ASA or nylon or polycarbonate. I have no idea how strong polycarbonate would be with carbon in it, but I would imagine it would be really strong, like beyond anything you're going to need. Polycarbonate in general could be good for something like a drone frame. This goes out to you, poor boy. I know you're really into that type of thing. The only issue I would say is, with the right amount of shock, like hard shock to it, it probably would shatter, but it'd make a really good frame. One of the reasons why I started printing with polycarbonate, actually, I never got around to it, was to print some small mini whoop frames for drones. And I wanted to do that, but build probably like a flexible filament sock to put around the outside of it. So if it did hit something hard, it wouldn't necessarily be directly on the polycarbonate. But yeah, those filaments are cool. I'd really like to do a video with that. Let's see here. Did there work filament Octopus Pro? Yep, on the probe port. Yeah, on the probe port. If I'm not, I'd have to look back, but I don't know there's a probe port per se on the breakout board I have. I'd have to double check on that. There must be though. Anyways, double check on it. Which manufacturer to what are you asking? Which manufacturer, Woody? Materials for plastics or something else? Carbon fiber filament has no strength benefit due to the non-weave of the fibers. Okay. Rich's comment. What was Rich's comment? Oh, Rich works for filament.ca, Woody. It's a Canadian filaments company that manufactures their own filaments. I do believe they ship to the US though, and Rich can back that up. I personally use a lot of, and I've mentioned it before, but I'll mention it again, a lot of Polymaker, who I need to talk to soon. A little Sparta 3D here and there, a little bit of eSun, and then I have a bunch of other stuff, just random. I have walls full of filament. Let's see here, what else we got? We got 3DX Carbonex, which is carbon fiber infused polycarbonate. Yes, extremely strong, and what, like $80 or $100 a roll? Not the cheapest stuff, probably not the stuff you want to learn how to do 3D printing with. Tensile strength is 70 MPa, megapascals. Yep, strong stuff. I got to a point with this camera. Let's see here, this one. I got to this point with this camera, I got torn apart. I didn't watch a video or anything like that, I should have. But this is going to get mounted inside the Voron. I do have a 4K nozzle camera going in there. This is going to be the top mounted point down camera, kind of the field of view camera. But what I don't know, and I need to go back and look, is exactly how or what they expect me to do to mount this. I could drill a hole or something through here on the ends and run, a pin or something through there, but I don't, it's kind of weird. I didn't see anything like that on the GitHub page that I got that from. So I'm gonna have to look at that. That's why I haven't put it back yet. That's kind of why I went away from it. It's just sitting here on the desk, in case you're wondering. I didn't break it, just a plus, right? Cool. Well, guys, that brings me up for the week. I'm wondering if poor boy actually sorted out anything, or if you're still in the same spot. Because if you are, this is a good time for me to make mention to the Discord channel for the folks that don't know about it. If you don't know about it by now, then you probably don't care. But poor boy, if you're still having an issue on that, I think I'll probably have a little bit of time. Maybe Rich will, maybe the rest of the folks all in this chat will have some time to maybe meet over there in the Discord, one of the live channels. We can talk a little bit about your problem if you haven't resolved it yet. I do want to know, before I end the stream where you're at. I don't want to leave you hanging. Reworking the firmware. Okay. When you say reworking the firmware, you're talking your printer.config file or the actual firmware? Because you're scaring me a little bit. Still scared. Anyways, all right, guys. If anybody has any questions or anything like that, by all means, leave me comments. Send me an email. My email address is kerm, K-E-R-M, at builditbasement, all one word, .com. I answer emails, I answer comments. I'm on the First Layer Discord. Rich, could you put up a link to the First Layer Discord before I close things off? Just in case anybody needs it. But usually over there at the First Layer Discord, one of us is at least on there all the time. If not multiples of us. Be scared. Well, the good thing about the config file, and I'll mention that real quick, and I was actually talking to Woody the other day. Let's see, thanks for all your help to one another. Yes, that's what we're all about. It's one happy family, right? Just to mention real quick, people don't know, I mentioned this to Woody the other day, is whenever you make modifications to your printer.config file on a Clipper printer, and this is in Fluid, but the same thing in Mainsail, is your printer is smart enough and nice enough to automatically make some nice backup files for you. So if the poor boy messes up his printer too far forward, we'll have to go back into some of his older printer config files, but no real worries there, so I don't have to be too scared, Nick. All right, Rich just put up a link there to the Discord. Hopefully, poor boy maybe meets us over there, and I invite everybody that's on the stream right now to come over there and kind of continue this a little bit. My caffeine level has come down. The video stream is almost done, and I've had a lot of fun with y'all. And that y'all is in reference to our southern folks. My Canadian friends, my friends around the world, my friends here in the States, I just want to say thank you, and I really appreciate the time that you spend with me. Hopefully you get something out of these videos, and I really, really, really want to continue doing them. And as much as the description of this video, if you did read the description, it says I'm all done making videos, it's not the truth. I really would like to have more time to make printers. It'd be nice if I could actually take 3 or 4 days and just build a printer and not have to worry about videotaping it. But you know what? Why not have 2 hobbies at the same time? They make YouTube videos. So with that, I say goodbye, and I hope everybody has a wonderful evening, the rest of the weekend, or whatever day of the week it is for you. Shouldn't be more than 1 day ahead of me, so. And I will see you during the week in a video about the printer. We'll be doing some electronics and some software on it. And if we're all lucky, including me, we'll do another live stream next weekend. So I say goodbye to all of you, and see you soon.